Hello everyone, welcome back with a new video. Today's topic is about the total internal reflection through the prisms. This topic is very important for the board exams. So let's start. See, the phenomenon of total internal reflection I will discuss in three cases. First one in three types of prisms. First one is the 90 degree, 45 degree and 45 degree prisms. Okay, second case will be 60 60 60 means for equilateral triangle, and third for 30 90 60. Okay, this is right angle triangle, this is equilateral triangle, and this is right angle isosceles triangle, and write the angles like this. This will be 90, this is 45. Okay, start from right angle isosceles prism, means whose one angle will be 90 degree and others angle will be 45 and the 45. This type of prisms are used in three purposes. First purpose is to deviate the ray, which means where the deviation will be, I am writing over here, deviation will be 90 degree. That I will explain. And see, the diagram will be like this, and here this angle will be 90, this angle 45, this is 45. So when the rays falls normally of one of its refracting surfaces, then it suffers total internal reflection. Now, how the deviation occurs over here? Choose one of the ray, you can choose 2 or 3, whatever. By one ray I am explaining. Suppose the ray is falling normally on that refracting surface. So we have read when the rays falls normally, then it goes without change in any direction. So it undeviates its path. That's why this diagram I have drawn. And when it falls over here, see, we have to calculate the angle of incidence over here, because we read the three cases when the rays falls at an angle below the critical angle, then it suffers normal refraction, and when I equals to C at critical angle, then R will be 90 degree, and when I greater than C, angle of incidence greater than critical angle, then there will be total internal reflection, TIR I am writing. Okay, so for glass, what is the critical angle for glass? Which is 42 degree. Okay, now we will check the angle is coming greater than 42 or less than 42. If it comes less than 42, then normal refraction. If it is going from denser to rarer, then it bends away from the normal, or rarer to denser, then towards the normal. That I will check over here. Now see here, this angle is 90. 90 45 means this is also 45. Okay, as this is 45, this angle will also be 45, which is greater than critical angle. So it suffers total internal reflection. Draw the line over here. Now see, again it is falling over here normally on that surface, so it undeviates its path. The direction will not change. Now see, what will be the deviation? See, in absence of prisms, the ray should go along this direction, but how much it deviates? This much. This is 90 degree. So here the deviation will be 90 degree. I have taken here one rays. You can take one more rays also. Same diagrams will come. This will be 90. Okay. This is how you can represent it. Means this right angled isosceles prisms is used to deviate the rays by 90 degree. Okay. This type of prisms are used in periscope instead of plane mirror. I told it because in case of plane mirror we did not get the 100% reflected rays, but by using the phenomenon of total internal reflection we get the 100% reflected rays. That's why in periscope this type of mirrors or these actions of the prisms are used. Second case for which the right angle isosceles prisms are used, that is to deviate the ray by 180 degree. Means when the deviation will be 180 degree. How? See, draw the figure like this. Okay, this angle is 90, this is 45, this angle is the 45 degree. Okay, so to deviate the ray by 180, took one object like this and think the light is going from, always take the light from two ends, then you will get the total image. Otherwise what will happen, if you take one rays from here, another rays from here, then up to this much image you will get. Okay, you will not get the total image. So that's why to get the total image you have to take the rays, one from one end and another from the other end. So take two rays. Okay, now see here we have to check the angle of incidence. If it is coming greater than 42, then it will suffer total internal reflection. See this angle 45, here it is 90 degree, so this angle will also be 90 degree. 90 45, so the remaining part will be how much? 45. So obviously this angle will be 45, which is greater than the critical angle, so it suffers total internal reflection. Okay, now when it falls over here, again we have to draw the normal, check the angle of incidence over here. See, as this angle is 45, this angle will also be 45 because I equals to R. Reflection, so angle of incidence equals to angle of reflection, laws of, it will obey the laws of reflection also. Total internal reflection also obeys the laws of reflection. That's why you can write this is 45, so this angle will also be 45. Now see how much this angle, see total 90 and this angle total will be 90, so the remaining part will be 45. As this is 45, this is 90, so this angle will be 45. As this is 45, this is normal, total angle 90, so the remaining part will be 45. Okay, so the angle of incidence over here, it is 45, which is greater than the critical angle. So again it suffer total internal reflection, and this angle will also be 45, and it is falling normally, so it deviates its path. Okay, up to this we got the rays, means this diagram we have drawn. Here take another rays from the other end. Again see the same case will happen, this angle will also be 45 degree, total internal reflection. Again, okay, draw the normal over here, this will come 45, same explanation. Now see this point, means this point, suppose AB name I am giving, this will be better. A point means which one? This is A point, A dash I am writing. Here B point means this is the B point, B dash I am writing. So arrow we have to give like this. Now see how much it deviates. Look, by one diagram I am telling, suppose this one. In absence of prism, the rays should go along this direction, but it deviates up to this much. So the deviation will be 90 degree over here. Now in absence of prism, the rays should go along this direction, but because of this prism, it deviates up to this much, which is 90 degree. How much it deviates total? There is no deviation, because deviation is how much? 0. Instead of prism or in absence of prism, the rays should go like this. So there is angle of deviation 0, here also 0. So only 90 plus 90, which will be 180. Okay, to deviate the ray by 180 degree, this type of prisms are used. Okay, so sometimes the question comes, deviate the ray by 180 degree, then this diagram we will draw. And the next type of problem comes, draw the ray diagram to get the erect image of an inverted object. That I am coming. The action of the prism means to deviate the rays by 180 degree. That actions of the prisms are used in camera binoculars like this. And here the third case, I will show how to get the erect image of an inverted object but without deviation. In previous case the topic was same, but there was the deviation which is 180 degree. But here the topic is same but without deviation I will show. So let's go. First you take one inverted object, I am giving the name A and B. So the rays, take the rays from both ends. So when the rays falls on the surface, then see what we know. When the rays goes from rarer to denser, it suffers refraction and it bends towards the normal. That's why the refracted ray will be like this. Okay. Now draw the normal over here. See, we want to find this angle, because if this angle comes greater than critical angle, then there will be total internal reflection. Now to find this angle, we need to know about this angle. See, this is 45, this total is 90, but wait, this small angle has some value. I am taking the minimum angle, which is suppose 1 degree. Now total will be how much? 91. 91 plus 45, how much? 91 plus 45, this will come 6 and 136. So the remaining part will be how much? This is 44. Okay, as this is 44, this will come 46. See, to explain this I took 1 degree, but actually this angle will be more than 1 degree, but for explanation I have given that value. See, means if you take any one angle, that value will come always greater than critical angle. That I am trying to explain. Okay, this value will come always greater than critical angle. That's why it will suffer total internal reflection over here. So draw the line. Okay. Now this angle will be 46 again. Okay, draw the normal. Now it suffers only the refraction because this angle of incidence is less. Okay. Now take the another rays from the other end, draw the normal, same diagram you draw. Again it will come greater than critical angle, it suffers total internal reflection. Okay, again draw the normal over here. So it bends away from the normal. Now see, this B point means which one? This is, so B dash I am giving. A points means which one? This one, so A dash I am giving. See, the arrow will be over here. Now that was the inverted object, but we got the erect image. Understood about this part? Angle, I took this minimum angle, but the value will be more than 1. So always it will come more than critical angle. Clear? So by which means this type of actions is action of the prism which is used to get the erect image of an inverted object but without deviation. How we are telling without deviations? Now see, here the ray is moving, the ray is falling along this direction. This is the incident ray, direction of the incident ray, and see, after passing through this prism we are getting the rays along the same direction. So is there any deviation? No, the deviation is means delta or deviation will be 0 degree because same deviation, and in previous case the deviation was 180 degree. Why? By this diagram also we can say, see, the diagram was like this and we took the object like this, and here this was incident ray and this was the emergent ray. Here see the direction, one is upward, one another is downward. If this is incident ray, direction of the incident ray, and this one is the direction of the emergent ray, how much it deviates? This much. How much? Angle is 180. Okay, clear? Actions of the prisms are used in the slight projectors. Okay, now I will show how the refraction occurs in the equilateral prism. Number 2 means the angle will be 60 degree, 60 degree, 60 degree. Okay, now to draw the diagram, first draw the prisms. Okay, so all the angles are 60. So consider the rays are falling. See, I have taken here one rays. You can take more than one rays also. Okay, so I am taking here one ray switching, falling normally on that surface A and B. It is falling normally on AB. So after refraction means as it is falling normally, so it undeviates its path. So there will be no change in direction. But when it falls over here, we have to find the angle of incidence. Because if it comes less than critical, then only the refraction. If it comes more than critical angle, then there will be total internal reflection. So to find out the angle, see, this angle is 60, that is 90, 9 plus 6, 150. So the remaining part will be 30. As this is 30, so this angle will also be 60. As this is 60, so it is more than the critical angle, so there will be total internal reflection. This angle will also be 60. But now see, that ray is falling normally with on the BC part. So there will be no deviation, the ray will move along this direction. This is the diagrams of the equilateral prisms. If I ask the question, what is the angle of deviation in this case? See, in absence of prism, the ray should move along this direction. But because of this prism, the deviation is this much. We have to calculate the total angle over here. Now see, here this angle is 60, means this angle will also be 60 because of vertically opposite angle. As this is 60, so we need to find this angle how much? See, so this angle 60, that is 90, 9 plus 6, 150, and the remaining part will be how much? 30 degree. Okay. Now see, only this much we need. So we got this angle also. This is how much? 30 degree. This angle 30. Okay. Now see, 60 plus 60, 120, that is 30. How much? 150. And the remaining part, obviously this will be 30 degree. So the total deviation 30 plus 30, how much? 60 degree. So here the angle of deviation will be 60 degree. Clear? See, again I am telling. See, okay, 60 degree, 90 degree, so the remaining part will be 30 degree. Clear? As this is 30, now see that if this is 60, this angle will also be 60 because of vertically opposite. Now 60, this 60, 60 plus 60, 120, 30, 150, obviously total 180, and the remaining part will be 30. So deviation how much? This 30 plus this 30, so total is 60. Clear? Okay? Yes, where I will use the 30 degree, 90 degree and the 60 degree prisms. So number 3, that is 30, 90 and 60, which is called the right angle prisms. First you draw, here 3 cases are there. For one case, see, total how many faces are there? 3 faces. So here in first case we will obtain the total internal reflection, but in the other cases there will be no internal reflection. That I will show. First one, draw the prisms. This angle is 60, 90 and 30. First you take the rays going from, means the ray is falling on AB. Okay, it is falling normally, so it undeviates its path. Now calculate the angle over here. This is 60, that is 90, 9 plus 6, 150. This angle is 30, so the remaining part will be 60. As this is 60 more than critical angle, there will be total internal reflection. This angle will also be 60. Okay. Now draw the normal over here. We have to calculate this angle. Now see, that is 30. So this angle is 90. Okay, wait. As this is 30, so this total is 90. So this remaining part will be 30. Okay. This is 30 plus 30. Total 60. And obviously this angle will be how much? 30 plus 30 is 60. So this total will be 120. But this is normal, so only this much will be how much? 90 degree. So this remaining part will be how much? 30 degree, which is less than the critical angle. So only there will be refraction, and it is going from denser to rarer. It bends away from the normal. Now we got the total internal reflection over here. Okay. Now in the second and third case, also there will be no total internal reflection when the rays falls on the ABC phase and the AC phase. Okay. Second case, I will choose the ray is falling on AB. Normally it is falling. See, there will be no total internal reflection. Why? That I will also explain. It is falling normally, so it undeviates its path. Okay. Draw the normal over here. Check the angle of incidence over here. See, this angle was 30. 60, 90. 30, this is 90. As this is 90, so the remaining part will be 60. Okay. As this is 60, that angle will be 30. Okay. Actually, the normal will be like this. Okay. This is 30, less than critical angle. It suffers only the refraction. It bends away from the normal because it is going from denser to rarer. Okay. Now, the third case is when the ray is falling on AC. See, suppose the ray is falling normally on AC. So it undeviates its path. Check the angle of incidence over here. That was 30, 60, 90. 30, that is falling normally, so this angle will also be 90 degree. Okay, that angle is 90 degree. So 90 plus 30, 120. So the remaining part how much? 60 degree. As this is 60, this angle will also be 30. As this is 30, less than critical angle, it suffers only the refraction and it bends away from the normal. Okay, this is the emergent rays. Clear? Now I will show one exceptional case. See, if we draw one perpendicular bisector, and if we bisect this angle, means 45, 45. So this is perpendicular bisector. So when the rays falls above the perpendicular bisector, there will be no total internal reflection. But when the rays falls below the perpendicular bisector, then there will be total internal reflection. See how? That I will show. Now look, that was B. Suppose the ray is falling perpendicularly on this surface. Okay, so the ray will come over here because it will not bend because it is falling normally. So draw the normal over here. Now check the angle of incidence, means this angle. See, this is 30. Okay, falling normally means this angle will be 90 degree. 9 plus 6, 150. So the remaining part how much? 30. As this is 30, this angle will also be 60 degree. As this is 60, so there will be total internal reflection. That I am trying to say. Now see, draw the reflected rays. Okay, this angle will also be 60 degree. Now draw the normal over here. Calculate the angle of incidence over here. I am erasing it. Okay. Now see, this is 60, that will be 30, that is 90 was there. 9 plus 3, 120, remaining part 60, that is 30, which is less than critical angle. So there will be only refraction which will bend away from the normal. Okay. This is the exceptional case. When the rays falls above the perpendicular bisector, then there will be no total internal reflection. But when the rays falls below the perpendicular bisector, then we can say there will be total internal reflection. Clear? In your exam, which type of problems will come? The incident ray will be given and the angle will also be given. Suppose this is the prism, 60 degree, 30 degree, 90 degree. How the question will come? Suppose the question will be like this. The rays are falling normally on AB phase. Complete the ray diagram like this. Or if I say this type of diagram will be given, means incident ray will be given. You have to finish the diagram. This type of problem comes in the exam. Okay. So up to this we read about the diagrams, but the question will be, what are the uses of this type of prisms? See, first one we read about the 45 degree means a right angle isosceles prism. So in that case we read to deviate the rays by 90 degree or to deviate the rays by 180 degree. So to deviate the rays by 90 degree, that type of prisms are used in periscope, and to deviate the rays by 180 degree, when the deviation was 180, then that type of prisms are used in camera, binoculars, like that. Okay, and there is one advantage of using prisms instead of plane mirror. We get, in case of prisms, there will be total internal reflection. So in case of total internal reflection, we get always the 100% reflected ray. But in case of plane mirror, no, actually the reflected ray is not 100% because some part of light gets absorbed. This is the main advantage of using prisms instead of the plane mirror. Okay, there are so many applications of total internal reflections. First one of the most important application is the mirage. On mirage I will make one separate video, that mirage which is observed in the desert. And next example is in case of diamond, it sparkles when it is viewed from a certain direction. Okay, and the third example is the optical fiber, which is used to transmit the signal over a long distance without much loss of energy. It is one of the most important application of the total internal reflection. Okay, so today's class up to this. In next class I will start the lens chapter. Okay, stay home and stay safe, but don't forget to study. Thank you.